morning, everyone. I hope you all are doing well. I hope you're staying safe. I know this is an unusual time and we're learning in a different capacity than what you're used to, but I have confidence that you guys are going to do amazing. So today we're going to start with lesson 6.3, solving systems using elimination. For this lesson, you will need paper to take notes with, a pencil to write them down, a basic calculator, whether it's a handheld, one from your cell phone, laptop, computer, tablet, etc. Homework 52, lesson 6.3b, solving systems using elimination. This homework assignment is found in the yellow folder that went home with you last week on Wednesday. So we're going to go ahead and get started. The first example that we're going to talk about, solving systems by adding equations, will be a quick review as you have been taught this prior to leaving for the break. So the quick review, in order to add, we're looking for the system to have the same coefficient but different signs. So if we look at this first set of equations here, we notice that the coefficient to the first x is 2 and the second x is 6. 2 and 6 are not the same number, so they do not meet the first qualification. As we move to the y, the coefficient of this first y is 5 and the coefficient of the second y is 5. So it meets the qualification. They have the same coefficient. The next qualification, they have to have different signs. What we do, we have a positive 5y and a negative 5y. So therefore, we meet the qualifications in order to solve our system by adding the equations. So we're going to go ahead, since we have all of that holding true, we're going to take our two equations. Sorry, I grabbed the wrong thing here, guys. All right, we're going to go ahead and add our two equations. So we have 2x plus 6x makes 8x. Positive 5y plus negative 5y is 0. 17 plus negative 9 here makes a positive 8. We will divide on each side by 8 to get the coefficient to 1 and leaving me with 1x. 8 divided by 8 is 1. In order to find the y value, you either pick the first equation or the second equation, and you substitute x for 1. Throughout this lesson, I will just use the first equation for substituting back in. So to do 2 times the x value plus 5y is equal to 17. We found the x value to be 1, so I will substitute with a 1. Remember, anytime you're going to do substitution, you want to make sure that you use parentheses to indicate where you are substituting your value at. So that if you have a negative value that would need to be substituted in, you do not mess up any mathematical operation. So always use parentheses when substituting. So we'll solve first. 2 times 1 is 2, plus 5y is equal to 17. We need to get the 5y all alone. So we need to move this constant to the right, to the right. The opposite of plus 2 is minus 2. And if we minus 2 on the left side, we must minus 2 here on the right side. 2 minus 2, eliminate, leaving me with a positive 5y. And 17 take away 2 is 15. We will divide each side by 5 because this is the coefficient of the y. And we want these coefficients to cross-cancel each other out, leaving me with 1y. And 15 divided by 5 is 3. We'll now write our answer as an ordered pair, which we put the x value first in every ordered pair, y value second. If by chance you don't have x and y's, you have other letters in the alphabet that you're solving for, always put them alphabetically. Because even in an ordered pair, x comes before y in the alphabet. So 1 and 3. This would be your final answer. We're going to go ahead and solve our second equation. over here. We're going to take a moment and look at this equation. We're going to examine our coefficients. So for the first set, our x, we have a +5 and a +5. So that meets the qualification for same coefficients. But it does not meet the qualification for different signs, because those signs are not the same. They are both positive. We had a little glitch in the system, so I want to make sure you guys heard that again. The coefficient to the x's are both 5, which means they have the same coefficient, but they do not meet the qualification of different signs. Both of these 5's are the same sign. We're looking for different signs. The coefficient of the y's are 6 and 6, so they meet the qualification of the same coefficients. And we have a negative sign and a positive sign, so they meet the qualification for different signs. Since we have that happening in our system, we can go ahead and add our equations. So we're going to go ahead and add these guys up. 5x's plus 5x's make 10x's. We were adding. Negative 6y plus positive 6y cancels out at 0. Negative 32 plus 48 is a positive 16. We'll take our equation now, and we'll divide each side by 10 because we want to get the 16 by itself. So just mark out these guys. They cross cancel, leaving me with 1x. And then we have 16 divided by 10, which is equal to 1.6 or 8/5. Either answer is fine for you to use because this 1.6 is a terminating decimal. That means it does not repeat and it does not go on for infinity. It has an ending point. It stops at 0.6. So now we're going to go ahead and substitute the value for x into our first equation. I'm going to just use the 8/5. That's okay with everyone. If not, you may feel free at home to use 1.6. Either way, you will get the same answer. So we have 5, and I'm going to substitute for x. So I use my parentheses to show I'm going to be using substitution. Minus 6y is equal to a negative 32. I'm going to substitute and put my 8/5 in my parentheses. 5 times 8/5. Notice these 5's cross cancel each other out, leaving me with 8 minus 6y is equal to negative 32. I need to get the negative 6y on the left side by itself to isolate the variable. So the opposite of plus 8 is minus 8. Then we have our minus 6y equals a negative 32. Plus 8 minus 8 is 0. But if I subtracted 8 on the left side, I have to subtract this 8 over here on the right side. Otherwise, my equation does not balance out. Then I have negative 6y, and then I've got negative 32. Take away 8 more is a negative 40. We'll now divide each side by negative 6 to isolate the variable and get just a single 1y. Negative divided by negative is that's right, a positive. So 40 divided by 6 would give me a repeating decimal, and we cannot write repeating decimals as solutions. We have to either round them or leave them as simplified fractions. For this lesson, we're going to leave them as a simplified fraction. So the negative divided by negative makes a positive. 40 and 6 are divisible by 2. So 40 divided by, say, negative 2 makes a positive 20. And negative 6 divided by a negative 2 equals a positive 3. So there is my answer for my y value. So the solution to my problem is 8/5 and 20/3. This is the solution to the second set of systems of equations. If you have any questions, please feel free to pause your video at any given time throughout the lesson, rewind it, look over, make notes. If you have any questions, write them down, take a picture, send them to me through Remind app, and I'll be more than glad to answer your questions at any time and send your replies back. All right, guys, we're going to move on to example 2, which is solving the systems by subtracting. So the two rules that we have here in order to subtract, just like the one rule we coefficient. So we're looking for the have the same coefficient. And the other qualification is they have to have the same sign. Means they're going to look like identical twins. Identical twins. So let's look at our first system of equations. We have a positive 2 and a positive 2. Same sign. So I mean, same coefficient. I'm sorry, guys. But they are also the same sign because it's a positive 2 and a positive 2. All right, so since we meet both qualifications already, there's no need to move any further in the problem. So we can go ahead and use solving the system by subtracting our equation. We're going to go ahead and subtract these two equations. So we're going to subtract the first column, subtract the two numbers in the second column, and subtract the two numbers in the third column. So 2x's minus 2x's leave you with 0x. 4 minus a negative 2. Minus makes a positive. That is right. So now we have like 4 plus 2, which is 6y, equals 22 minus negative 8. Again, we have a minus. So remember, a minus is a, you got it, a positive. So 22 plus 8 is equal to 30. We will now divide on each side to get the y by itself for 6. So we divide each side by 6, so we leave us with 1y, and 30 divided by 6 is 5. Now I'm going to go ahead and substitute the y value into the first equation to find the x value. So we have 2x plus 4, and then parentheses to show I'm going to be substituting for my y value, is equal to 22. And I'm going to go ahead and substitute that 5 and where I put my parentheses. Before I can go any further, I have to solve this operation of 4 times 5 first. So 4 times 5 is equal to 20. And it's equal to 22. I need to get the 2x by itself, so the opposite of plus 20 or positive 20 is minus 20. And if I subtract 20 on the left side, I have to subtract 20 on the right side. The plus 20 and the minus 20, well, they cross cancel each other out, leaving me with 2x. 22 minus 20 is equal to 2. We'll divide each side by 2. The 2's cross cancel out, leaving me with 1x. And 2 divided by 2 is 1. So my final answer, again, remember in alphabetical order, x is 1, y is 5. Here is the answer to the first system of equations. All right, we're going to move on to our second system of equations. We're going to check and see if we meet the two qualifications in order to subtract these two equations. So let's look at our coefficient to the first x is 4. The coefficient to our second x is an understood 1. 4 and 1 do not have the same coefficient. So we do not even need to check those anymore. We need to move on because they have to meet both qualifications in order to subtract. So automatically move on to the next one. The coefficient of the first y is 7. The coefficient of the second y is 7, so that meets the qualifications to same coefficient. We now have to look at their sign. The coefficient of the first equation is a negative 7, and the second one is a negative 7, so they have the same sign. Now we have a pair of variables with the same coefficient and the same sign, so therefore we can subtract our equation. So we're going to go ahead and do that. I'm going to erase some of this out so we don't have it interfering. So we're going to subtract the first column, the second column, and the third column. So I'll throw 1 back so you can see that. So 4 minus 1 is 3. Negative 7 minus negative 7. Remember, the minus makes a positive. That's correct. So it's negative 7 plus 7, which is 0. Then we'll subtract the constant. 3 minus negative 15. Minus makes a positive. So we got 3 plus 15, which is 18. We will now divide each side by the coefficient of 3. The 3's cross cancel each other out, leaving you with 1x. And 18 divided by 3 is 6. We're now going to go ahead and substitute the x into the first equation. So we have 4. Again, I'm using parentheses to show substitution. Minus 7y is equal to 3. I'm going to put my 6 into parentheses where I'm showing substitution. I will first solve 4 times 6, which is 24, minus 7y is equal to 3. We need to get the negative 7y by itself, so we have to move the 24 to the right. So the opposite of plus 24 is minus 24. And then we have minus 7y equals 3. And if we subtract 24 on the left, we have to subtract 24 on the right. So 24 minus 24 cross cancel each other out, leaving you with a negative 7y. And 3 take away 24 is a negative 21. We will then divide each side by negative 7. The negative 7's cross cancel each other out, leaving you with a 1y. Negative 21 divided by negative 7 is a positive 3. So now we have our answer. Our x value is 6, our y value is 3, and that is the final answer to our solution. All right. Again, if you have any questions, please feel free to write them down, take a snapshot, upload them to me in Remind, and I'll be more than glad to send your response back. All right, we're going to move on to example 3, solving a system by multiplying one equation. So we're going to multiply one of the equations by a value and leave the other equation as is. So what we're going to do for this is we're going to look at each of our two equations in each system. So you look at system number 1, system number 2, and system number 3. In the first system, we're going to look at the coefficient and see if either coefficient will divide into the other one equally. For instance, will 2 go into 7 even? No, it goes into 7 3 times, but we have a remainder of 1. Then we ask, will 7 go into 2? No, 7 cannot divide into 2. So we can't use the x's. Then we move on to the y's. We ask ourselves, will 15 divide into 5? No, 15 cannot divide into 5. Then we ask, will 5 go into 15? Yes, 5 goes into 15 3 times. This means I can multiply my 5 by 3, and it would give me 15. This would mean I would have my y's would now have the same coefficient. If I look at my x's over here, I can't say 7 times anything, some unknown value would not give me 2. And there's 2 times some unknown value would not give me 7. This is not workable. But in this case, I can take my 5 and multiply it by 3 and get 15. So that is what we're going to do to solve these equations. Again, you can pause the video as you need to. All right, so since we said that we could multiply this 5 by 3 to get 15, it means we'll now have to multiply everybody on the bottom equation by 3. We have to multiply the 7x times 3, the negative 5y times 3, and the 17 times 3. Since the first equation already had a 15 here as a coefficient to the y, I don't have to do anything to that equation except rewrite it. So I'm going to rewrite it as negative 2x plus 15y is equal to negative 32. There were no changes made to it because it had the coefficient that I wanted, and that was 15. So now I'm going to distribute 3 times 7, making 21x. 3 times negative 5 makes negative 15y. And 3 times 17 is equal to a positive 51. Now, from the quick review from examples 1 and 2, once you get to here, you're determining, are you going to add the two equations or subtract the two equations? Remember that the first qualification for either one, for adding or subtracting, is that they had to have the same coefficient. And we did that. We created and made them both 15 on the y. The second qualification determine whether you were adding or subtracting. If they had different signs, we were adding. If they had the same sign, we were subtracting. Remember in class I taught you same sign subtract, like a snake. So it's same sign subtract, identical twins subtract, but different signs we are adding these guys. So we're going to add up all three columns. We'll add the first column together, the values of the second column, and the values of the third column. So negative 2 plus 21 is a positive 19x. Positive 15y plus negative 15y is 0. Negative 32 plus a positive 51 is 19. We'll divide each side by the coefficient of 19 so that we can get the variable x by itself, leaving me with a 1x. And 19 divided by 19 is 1. I will now substitute my value of x into the first equation. So I have negative 2, showing parentheses where I'm going to be substituting, plus 15y is equal to a negative 32. I'm going to put my x here in the parentheses to show where I put my substitution. Got to multiply the negative 2 times 1 first, which makes negative 2, plus 15y is equal to negative 32. I need to get the negative 2 away from the 15 and y because I want the 15y on the left side here all by itself. The opposite of a negative 2 is a plus 2. And if I add 2 on the left side, I have to add 2 on the right side. Negative 2 plus 2 cross cancel each other out, leaving me with 15y. And negative 32 plus 2 is equal to a negative 30. I will then divide each side by a positive 15, so I can isolate and get the y as a coefficient of 1. And negative 30 divided by 15 is a negative 2. So my final answer is x is equal to 1 and y is equal to negative 2. All right, we're going to move on to the second system of equations. If we look at the coefficients to our x's, I ask myself, will 2 divide into 1? No, 2 cannot divide into 1. Then I'll ask myself, can 1 go into 2? Yes, 1 goes into 2 times. So now I do not need to worry about the y values. I found everything I needed with the x values. This means I can multiply the bottom equation by 2. By doing so, it would be a 2x, just like the first equation is a 2x. Since I didn't do anything in the first equation, I'm going to go ahead and leave the first equation just as it is. 2x plus 3y is equal to 9. The second equation, I'm going to distribute. 2 times 1x is 2x. 2 times 5y is 10y. And 2 times 8 is 16. So remember again, from example 1 and 2, we have made them to the same coefficient. So that qualification is the same for both adding and subtracting. But now we're looking at the signs. If they have different signs, like in our first set of equations, one's a positive and one's a negative, well then we add. But if they have the same sign, they're both positives or they're both negatives, in our case they're both positives, we have same sign subtract or identical twins and we subtract. So we have 2 take away 2, which is 0x's. 3 take away 10 is a negative 7y. 9 minus 16 is a negative 7. We'll divide each side by negative 7 in order to get a 1y on the left side. And negative 7 divided by negative 7 is a positive 1. I will now substitute that positive 1y into the first equation. So I'm going to do 2x plus 3 times the y value equals 9. And I'm going to substitute that y value with 1. Remember, parentheses when substituting. So 2x, now solve 3 times 1 is 3, is equal to 9. I need to get the 2x by itself, so I will subtract 3 on the left, and I will subtract 3 on the right. 3 minus 3, they eliminate. 2x is equal to 6. We'll divide each side by 2, so we get a 1x. And 6 divided by 2 is 3. So my final answer is x is equal to 3, and y is equal to 1. All right, we're going to move on to our final example. Notice this time that if I say, will 6 divide into 7 evenly? No. Will 7 go into 6 evenly? No. Then I ask myself, will 3 go into 4 evenly? No. Then will 4 go into 3 evenly? No. That's different from the first two. When you come to this type of situation, you can choose to multiply either the top equation or the bottom equation by each a different number. We're going to go ahead and save this guy for a little bit later. So he does not meet the example 3, solving a system by multiplying one equation. This guy will require us to multiply both equations. And for today's lesson right now, we're dealing with multiplying only one equation. So we're going to go ahead and X him out for now and leave him for a little bit later. All right, so what I'm going to do is give you some practice time. So practice time means, for you guys, is when we get done going over all the instructions, I want you to freeze or pause your screen for the moment, your video. You'll try to solve problem 1 and problem 2 in the practice. When you feel like you've completed your problem, you'll go ahead and hit play on your button. When you hit play, I'm going to be showing you how to solve the problems and explaining everything. You check your work and make sure you get the answers correct. Again, if you get stumped or have any questions, you can play the video. You can write down notes. You can ask me questions to remind. So we're going to go ahead and get started. So go ahead and pause your video at this time, and I'm going to go ahead and start explaining the problems. All right, so for problem number 1, what we want to do here is solve the system. First, we're going to ask ourselves to look at our coefficients. The coefficients of my x's are 3 and 2, so they're not the same coefficient. So I want to move on. The coefficients of my y's are 1 and -2. They're not the same coefficient. So since they do not have the same coefficients, I can't automatically add or subtract because that is the first qualification to both methods. So now I'm going to ask myself, will 3 divide into 2 evenly? No. Will 2 divide into 3 evenly? No. So I can't adjust the x's. So then I look at my y's and I say, will 1 go into 2 evenly? Yes. 1 will go into 2 times. That means I'm going to multiply everyone in the first equation by 2 and leave everyone in the second equation as is. So I'm going to use my distributive property. 2 times 3x makes 6x. 2 times 1y makes 2y. And 5 times 2 makes 10. And again, I'm going to leave the second equation as is because it already had a 2 as a coefficient for my y value. Now I know they both have the same coefficient of 2, so they meet the first qualification for both methods. The second qualification is if they are different signs, I add. If they are same signs, I subtract. Well, my coefficients are different signs, so that means I will add all 3 columns. 6x's plus 2x's make 8x's. Positive 2y plus negative 2y is equal to 0. 10 plus negative 2 is equal to a positive 8. I will now divide each side by positive 8. 8 divided by 8 leaves me with 1x, and 8 divided by 8 is 1. I will now substitute into the first equation. So I have 3 times my x value that I'm going to substitute in, plus 1y is equal to 5. I'll replace my x with a 1. 3 times 1 is 3, plus 1y is equal to 5. I want to get the 1y all alone, so I do the opposite of a positive 3, which is a minus 3. And if I subtract 3 on the left, I must subtract 3 on the right. 3 minus 3, eliminate, leaving me with 1y. 5 minus 3 is equal to 2. So the answer to my first set of systems is x is 1, y is 2. I hope you guys did really well on that and got that for your answer. If not, please look to the work and see where you may have gone wrong. We're going to move to practice time number 2. I asked myself, will 6 go into 3 evenly? No. Will 3 go into 6 evenly? Yes. 3 goes into 6 2 times. So I don't need to look at the y values. That means 3 can go into 6 2 times, so I can multiply 3 by 2 in order to make it a 6. Since I do nothing to the first equation as it is already a 6, I will leave that first equation just as it is. So 6x plus 4y is equal to 42. I will now distribute and multiply the 2 times every value on the bottom equation. So 2 times negative 3x makes negative 6x. 2 times 3y makes a positive 6y. And 2 times negative 6 makes a negative 12. So now my systems, the coefficients of my x's are the same, so they meet the first qualifications for both methods, which means they have to have the same coefficient, and they have the same coefficient of 6. The second qualification is either same sign or different sign. Different signs we add, same sign subtract. So my coefficients are positive and negative, which means they are different signs, so we add. So we're going to add all 3 columns. 6 plus negative 6x is 0. Then we have 4y plus 6y makes 10y. Then we have 42 plus negative 12 makes 30. We'll divide each side by 10 to get the y by itself. And then the 10s will cross cancel each other out, leaving me with 1y. Then 30 divided by 10 is equal to 3. I will now substitute my y value into the first equation. So 6x plus 4 times the y value is equal to 42. And I'm going to substitute 3 into the y spot. So now I have 6x plus 4 times 3, which is 12, equals 42. I need to get the 42. So the 6x by itself, let me eliminate all together. You need to get the 6x all by itself. So I'm going to do the opposite of plus 12, which is to minus 12. And if I have minus 12 on the left side, I must minus 12 on the right side. Plus 12 minus 12 cross cancel each other out, leaving me with 6x. 42 take away 12 is 30. Divide each side by 6. The 6 is cross cancelled, leaving is 1x. And 30 divided by 6 is 5. So your final answer is x is 3. So x is 5 and y is 3. This back. X is 5 and y is 3. This is your second. If you got this answer right, give yourself a whoop whoop in the house and a pat on the back. All right, we're going to move on to example 4. This is the one where I told you a second ago we left the one equation alone because now we're going to multiply both equations. So in order to solve these systems of equations, we have to multiply both the first equation and the second equation by the same value. So this is what we're going to go ahead and do. The easy way I can tell you to solve these is to go ahead and just look at the x's. It makes it quicker and easier for you to solve less work. So if you take the coefficient of the second equation, which is 4, and we're going to multiply the first equation by that. Then we'll take the coefficient of the first equation, which is 3, and we're going to multiply the second equation by that. By doing so, I know that 3 times 4 is 12, and since 3 and 4 are both factors of 12, that means they both have to be divisible by 12. So here we go. So we're going to multiply 4 times 3, and then 4 times 2, and then 4 times 1 to get our first system. So 4 times 3 is 12x. 4 times 2y is 8y. And 4 times 1 is 4. Then we're going to multiply 3 times everyone on the bottom. So 3 times 4x is 12x. 3 times 3 is 9y. And 3 times negative 2 is negative 6. So now we've met the qualification for both methods. The first one, they have the same coefficient of 12. The second qualification, remember, if they have different signs, we add. If they have the same sign, we subtract. So since they have the same sign, they're both positive 12, we will subtract. We will subtract all 3 columns. So 12 minus 12 is 0. 8 minus 9 is a negative 1y. 4 minus minus, remember the minus minus is that's right, a positive. So 4 plus 6 is 10. We need to divide each side by negative 1 because we want to get our coefficient to be a positive 1y. And 10 divided by negative 1 is a negative 10. We will now substitute negative 10 for the y value into the first equation to find the x value. So we're going to do 3x plus 2, the y value, equals 1. Again, I put parentheses to show that I'm substituting. So I'm putting in a negative 10. And this is where it becomes important that you put those parentheses so we don't mess up on our sign. So we got our 3x, so we got to solve 2 times negative 10. 2 times negative 10 is negative 20. So we write it as a minus 20. This equals 1. We need to get the 3x by itself. So the opposite of minus 20 is plus 20. And if we add 20 on the left, we have to add 20 on the right. Negative 20 plus 20 cross cancel each other out, leaving you with 3x. And 1 plus 20 is 21. We now divide by 3, so we can have a positive coefficient of 1x. And 21 divided by 3 is a positive 7. So the answer to my first system of equation is x equals 7 and y equals negative 10. So example 4, second set of systems of equations. We'll do the same thing. We'll take our second x value, which is 3, and multiply that by the first equation. And we'll take our second equation and multiply it by the coefficient of the first equation, which is 4. So we're going to multiply everyone on the top by 3. So 3 times 4x makes 12x. 3 times 3y makes 9y. And 3 times 19 equals negative 19, the negative 57. Now we're going to go ahead and multiply the second equation, everybody by 4. 4 times 3x is 12x. 4 times negative 2 is negative 8y. And 4 times negative 10 is negative 40. So we've met the first qualifications for both methods, making our values, our coefficients the same value, which they're both 12s. To add, they have to be different signs. To subtract, they would be same signs. So our coefficients are both a positive 12. Since we have same signs, we will subtract. We'll subtract all 3 columns. So we'll do 12x minus 12x, and we'll get 0. We got 9 minus negative 8. Remember that minus minus makes a positive. So now that would make 9 plus 8, which is 17y. Then we're going to do negative 57 minus minus. Again, a minus minus makes a, that's right, a positive. So that negative 57 plus 40, which equals a negative 17. We will now divide each side by 17 in order to get a coefficient of 1y. Negative 17 divided by positive 17 is equal to a negative 1. So So now I know my y value, so I'm going to substitute it into my first equation. So I have 4x plus 3 times my y value equals negative 19. I'm going to put a negative 1 in here. So I got to solve. 3 times negative 1 is negative 3. Now equals negative 19. I want to get the 4x all by itself. So the opposite of minus 3 is plus 3. And if I add 3 on the left side, I have to add 3 on the right side. Negative 3 plus 3 cross cancel each other out, leaving me with 4x. And negative 19 plus 3 is a negative 16. We'll divide each side by 4. The 4's cross cancel, leaving me with a 1x. And negative 16 divided by positive 4 is a negative 4. So my final answer is x is equal to negative 4 and y is equal to negative 1. That is the answer to my second system of equations. If you have any questions, please feel free to write those down and send them to me through the time. Now it's practice time. So again, just like the previous practice time, you'll pause the video, you'll work on the 2 problems. When you're ready to check your work or make sure you're going in the right direction, you'll resume your video, and then you'll be able to see the work that I have completed. So this time, go ahead and pause your video. I'm going to start solving the problems. Good luck. All right, since the coefficient of my x's are not the same, and the coefficient of my y's are not the same, and 3 does not go into 2, and 2 does not go into 3, and 2 does not go into 5, and 5 does not go into 2, I will have to multiply both equations by a single number. So I'll multiply the first equation by the coefficient of the second equation, which is 2, and I'll multiply the second equation by the first coefficient of 3. So to distribute, 2 times 3x makes 6x. 2 times 2y makes 4y. And 2 times 17 makes 34. I'll multiply the second equation by 3. 2x times 3 is 6x. 3 times 5y is 15y. And 3 times 26 is 78. So now I have created them by x's that have the same coefficient. Okay, so now, since they have the same coefficient again of both is positive 6, they have the same sign, so that second qualification of same sign means we subtract. Same sign, subtract. So you'll subtract 6x's minus 6x's are 0x's. 4 minus 15 is equal to a negative 11y. And then we're going to do 34 minus 78. And you will get a negative 44. We'll divide each side by negative 11. Negative 11s will cross cancel, leaving me with a positive 1y. Negative 44 divided by negative 11 is a positive 4. I will now substitute the 4 back into the first equation. So I've got 3x plus 2 times the y value is equal to 17. And I'll put 4 in from my y value. I will first solve 2 times 4, which is positive 8, equals 17. To remove my 8, I will subtract 8 from each side, because plus 8 minus 8 are opposite. If I subtract 8 on the left, I must subtract 8 on the right. Plus 8 minus 8 go away, leaving me with 3x. And 17 take away 8 is 9. Divide each side by 3 to get the coefficient of a positive 1x. And 9 divided by 3 is 3. So the solution to my first system of equation is x is equal to 3 and y is equal to 4. I hope you guys did really good on that one. Ooh, I'll be so excited. So my second one, 5 does not go into 3 evenly. 3 does not divide into 5 evenly. 9 does not divide into 8 evenly. and 8 does not divide into 9 even. So I'll multiply the entire first equation by the second coefficient, the first coefficient of the second equation, which is 3. And I'll multiply the second equation by the coefficient 5 of the first equation. So I'll multiply every one on the top by 3. So 3 times 5 is 15x. And 3 times negative 9 is negative 27y. And 3 times negative 43 is equal to a negative 129. I will now multiply everyone on the bottom by a positive 5. So 5 times 3x is 15x. 5 times 8 is a positive 40y. And then 5 times 68 is equal to 340. Now I've met the first qualification for both methods, creating the same coefficient of a 15. I now look at the signs to determine whether I add or subtract. If they are different signs, we add. If they're same signs, we subtract. The 15 have the same sign, so we subtract. And we'll subtract all 3 columns. 15 minus 15 gives me 0x. Negative 27 minus 40 is equal to a negative 67y. Negative 129 minus 340 is equal to a negative 469. We'll divide each side by a negative 67 in order to get a positive coefficient of 1y. Negative 469 divided by negative 67 is a positive 7. I now will substitute my 7 for y into the first equation. So I have 5x minus 9 times my y value equals negative 43. I will substitute into the y value a positive 7. So I've got my 5x. I must solve negative 9 times positive 7, making a negative 63 equals a negative 43. I need to get the 5x by itself, so I'll do the opposite of minus 63, which is plus 63. And if I add 63 on the left, I will need to add 63 to the right. So negative 43 plus 63. I have 5x, because negative 63 plus 63 cross cancel each other out. Negative 43 plus 63 is equal to 20. I will divide each side by 5. The 5's cross cancel leaves me with a positive 1x. 20 divided by 5 is 4. So now I have my final answer. X is equal to 4, y is equal to 7. That is the answer to my second system of equations. I hope you guys did good. If you did great, give yourself a whoop whoop in the house and a pat on the back. Whoop whoop. All right, guys, we're going to move on to example 5. In this example, we're going to review, we touched a little bit about this right before we left again for the long break that we had. We talked about one solution, no solution, and infinitely many solutions. So in our one solution is when we solve these two problems like we have been doing already. So we're going to kind of solve them like we have been doing. Then we'll look at the answer and give you more detail about one solution, no solution, and infinite many solutions. All right, so to be our one solution, we want to make sure that we have just one solution. In order to have one solution, you're going to have a value for x, and you're going to have a value for y. So let's look at our first qualifications for both methods. Let's look for the variable that has the same coefficient. The x's have two different coefficients. They have a 3 and a 4. But the y's have the same coefficient of 2, which meets the first qualification for both methods. The second qualification is to look at the signs. Well, the first 2 is negative. The second 2 is positive. So the method that says when the signs are different, we Add, that's correct. So we're going to use addition method. So we're going to add all three columns. 3x plus 4x makes 7x. Negative 2y plus positive 2y cancels each other out. 0 plus 14 is 14. We'll divide each side by 7. So we can cross these out and have a positive 1x. And 14 divided by 7 is 2. So now I have a solution for x. I will substitute it into the first equation to find the solution for y. So we have 3 times the x value minus 2y is equal to 0. Substitute x for 2. 3 times 2 is 6. Minus 2y is equal to 0. We need to get the negative 2y by itself. So the opposite of plus 6 is a minus 6. Then minus 2y is equal to 0 minus. 6 minus 6 cross out, leaving me with a negative 2y is equal to 0 take away 6 is a negative 6. Divide each side by negative 2 so that we get a positive coefficient of 1y. And negative 6 divided by negative 2 is 3. Notice we got one solution. X is equal to 2 and y is equal to 3. We found a value for x and we found a value for y, thus creating one solution. For a no solution, we're going to look at our equation. We notice that the coefficient of our x's are both 9, and the coefficients of our y's are both 8. So, and now I look at the coefficients of my 9's, they have the same sign. The coefficient of my 8's have the same sign. So if they have the same sign, that's right, subtract. We're going to subtract both of these equations. So 9x's minus 9x's leave me with nothing. 8y minus 8y leaves me with nothing. So I have absolutely nothing left on this left side. It completely zeroed out. 15 minus 30 is equal to a negative 15. So you're looking at this and you're saying, will 0 ever equal negative 15? And will negative 15 ever equal 0? Will they be the same value? 0 can never be the same value as negative 15. And negative 15 can never be the same value as 0. So when you have your variables both eliminate, and they do not equal 0 on the right side. So we have a 0 equaling a number other than 0, then we have what's called a no solution. So we have a no solution here because 0 will never equal negative 15. So this is a no solution. So when your variables are completely identical, when the first system of equations have the same variables, 9x plus 8y, and the second equation has the exact same variables, 9x plus 8y, they're going to zero each other out. And as long as these two numbers on the back end are different, you will have a no solution. Let's look at our third example of the I, which is the infinite many solution. So we just notice that 2 and 1 are not the same coefficient. 6 and 3 are not the same coefficient. So before I can choose either method used to solve, I have to first get them to have the same coefficient, as that is the qualification for both methods. So I'm going to multiply the first equation by the coefficient of the second, which is 1, and I'm going to multiply the second equation by the first coefficient, which is 2. Since I'm multiplying by 1 on the first, that doesn't mean I don't have to do anything. It says 1 times anything is already whatever it is. So we'll have 2x plus 6y is equal to 18. We'll then multiply the second equation all by 2. So 2 times 1x makes 2x. 2 times 3y makes 6y. And 2 times 9 is equal to 18. Now, take a moment and look at these two equations. What do you notice? That's right. They are both completely the same. There are two identical equations. So when your equations are completely identical to one another because these guys have the same sign, they have the same coefficients of 2, the same coefficient of 6, and just like the problem we had a second ago, when the first equation and the second equation have identical x's and y's, when you subtract, they would eliminate, giving you 0. But unlike the second system, 18 minus 18 is also 0. Will 0 equal 0? Always will 0 equal 0. So when your equation comes down to 0 equaling 0, this results in an infinitely many solutions. Infinitely many solutions. So our answer is infinite many solutions. So let's review those one more time. If we can solve the equation and find the value of a variable and be able to substitute that value back into the equation to find the remaining variable, that is a one solution. If when we go to add or subtract our two equations and the variables completely eliminate themselves, becoming 0, and the constants produce a number other than 0, we get a no solution. If we go to add or subtract, and our variables eliminate themselves, becoming 0, and our constants eliminate themselves, also becoming 0, then we have infinite many solutions. So at this time, I want you to go ahead. We're going to do practice 5, example 5 practice time. So again, you will pause your video. You will solve these 3 problems. When you feel like you have the answers and are ready to check, you will press play, and then you'll resume the video and check to make sure you did okay. So now I'm going to go ahead and solve these. So at this time, please pause the video. All right, first ask myself, 3 and 6 are not the same coefficient number. 4 and 8 are not the same. Then I ask myself, will 3 go into 6 evenly? Yes, 3 goes into 6 2 times. Then I multiply everyone on the first equation by 2. So 2 times 3x is 6x. 2 times 4 is 8y. And 2 times 24 is 48. The second equation already has a coefficient of 6, so I'm going to leave the second equation as is. I notice here that both 6x plus 8y is the same as 6x plus 8y. That means they're completely the same number with the same sign, so it means I'm subtracting. Which means 6 minus 6 is 0, and 8 minus 8 is 0, leaving with 0 variables left over. And 48 minus 24 is a negative 24. And I know that 0 will never equal 24, so this is a no solution. For my second example, well, 5 and 10 are not the same value. 3 and 6 are not the same value. But 5 will go into 10 2 times, so I can multiply everyone on the first equation by 2. So 2 times 5 makes 10x. 2 times negative 3 makes negative 6y. And 2 times 10 makes 20. The first equation already has a 10x, so I can leave it as is. 10x plus 6y is equal to 20. Even though they look similar, they're not similar. So we're going to go ahead and use our multiplier method. They have the same sign, so that means the qualifications for both methods. They have the same sign, so same sign means to subtract. So 10 minus 10 is no x's. Negative 6 take away 6 more is a negative 12y. And 20 minus 20 is 0. I divide each side by negative 12. And then I get a positive 1y is equal to 0. So 0 divided by negative 12 is 0. So I know this will have one solution because I found a value to a variable. I will take the value for 0 and plug it in the first equation to solve for x. So 5x minus 3 times the y value is equal to 10. And my y value was 0. So I've got negative 3 times 0, which is just still 0, is equal to 10. Well, the opposite of minus 0 is plus 0. And if I had 0 on the left, I have to have 0 on the right. These cross cancel out. There's really no such thing as negative 0, but I just want you to see where it went from. 5x is equal to 10. Divide each side by 5. The 5's cross cancel, leaving me with it positive 1x, and 10 divided by 5 is 2. So I have one solution to my equation. X is 2, and y is 0. So one solution. All right, our third set. So we have 2 and 6 are not the same. 5 and 15 are not the same number. But 2 will go into 6 3 times, so I'm multiplying everyone on the top by 3. Giving me 6x minus 15y, and 3 times 17 is 51. The second equation has a 6x, so I'm okay. So 6x minus 15y equals 51. My equations are both identical. If both of my equations are identical, when I subtract, everything will zero out, leaving me with infinite bad handwriting there. Maybe it's better. You guys can read it better. Sorry, guys. Makes this infinite many solutions. I hope you guys did really well on today's lesson. If you guys have any questions, please write those down. Send me pictures, set them up to remind. I'll be more than glad to answer those questions and send those back to you guys. I love and miss you all so much, and class was not as exciting today without you in the room. I just hope you guys are doing well. Love you guys and hope you do well.